adding and multiplying data with constants. So in this topic, we're gonna see how the data changes, how the measures of dispersion changes if we add some constant value to all the data observations. For example, in any competitive exam, for one question, there will be four options, right? In this, one option will be correct. But for example, there is a printing error, so all the four options are incorrect. So at that time, the correction is made in such a way that all the students will be awarded a bonus mark to this question. So all the marks of each student, so marks of each student will be increased by +4 if the bonus mark is for 4 marks. Okay. So this is a basic general example where we add the constants to the data. So let's talk in terms of measures of dispersion. How do they actually change? Now let's talk in terms of measure. Now let's see how the measures of dispersion changes. For example, if there is a data with the data points x1, x2, x3, and so on till xn. This is the original data. For this, what will be the mean is? Mean will be sigma xi minus here the mean will be sigma xi upon n. N is the total number of observations. This is the original mean or the old mean. Okay. Now, if we add a constant for all the data observations, like let a is a some constant value. So we are just adding this a to all the data points. Now let us see how the mean changes. Now the new mean will be sigma of xi plus a upon total number of observations. Now we can split it like sigma xi upon n plus sigma a upon n. Sigma xi upon n is nothing but a old mean, right? So it becomes, now this is new mean, okay? Now this is old mean. Plus a is a constant. So bring it out. The remaining will be 1 upon n. Now this gets cancelled. Therefore, new mean will be old mean plus the constant value. So one thing you need to remember over here is when any constant value, when any constant value is added or subtracted, then the new mean will also get added by the same constant value. Right? When any constant value, here the constant value is a, is added or subtracted. This have proved by doing the addition. Subtraction is nothing but the adding the negative values, right? Then the new mean will also be added with the old mean by the constant value A. Now, how the variance or the standard deviation will change when we add a constant value. So let's see that also. Again, the same original data, that is x1, x2, x3, so on till xn. For this, what will be the standard deviation? Sigma xi minus x bar upon n under root. Sorry, this is the square, right? Yeah, this is the square. Now, if we add a constant value to all the data points, that is x1 plus a, x2 plus a, x3 plus a, so on till xn plus a. This is the original standard deviation. Now, the new standard deviation will be sigma xi plus a, because we are adding a constant to all the data points, minus x bar. X bar is nothing but mean. Just now we have discussed, if a constant value is added to the data, then the mean also will get added. So it becomes x bar plus a whole square upon n under root. Now, if you simplify it, sigma xi plus a minus x bar minus a whole square upon n. Now this a and this a will get cancelled. So it remains with sigma xi minus x bar whole square upon n under root. So it is nothing but original standard deviation itself. So here we need to remember is, if a constant is added to all the data points, the standard deviation gonna remain same. When we add or subtract a data point, similarly, the standard, similarly, variance, that is square of standard deviation, will also remain as it is. So when we add or subtract a constant to the data, the standard deviation as well as the variance remain as it is. They do not change. Only the mean changes, that too the old mean plus the constant value. Till now, we have seen how the measures of dispersion changes when we add or subtract the data. Now, let's gonna see how the measures of dispersion changes when we multiply or divide the data. So here, the original data will be same, x1, x2, so on till xn. For this, original mean will be sigma xi upon n. Okay. Now, if we multiply a constant value to the given data, again assume the constant value is a. So it will be ax1, ax2, so on till a times xn. Then the new mean will be sigma axi upon n. A is a constant, bring it out. So a into sigma xi upon n. This is nothing but the old mean. So therefore, new mean is nothing but a times of old mean. So you need to remember here is, when we multiply a constant value or divide a constant value, the mean will be constant value times of the old mean. Divide, why I'm saying divide? Here a can be 2 or a can be 1 by 2 also. We are multiplying it with the inverse of the value, right? So it can be a multiplication or a division. Now let's see how the standard deviation and variance changes. So for the original data, that is x1, x2, so on till xn. The standard deviation will be sigma xi minus x bar whole square upon n under root. If you multiply the data with a constant value, then the new standard deviation, this is the original, the new will be sigma a times of xi minus, just now we have seen, mean also will be a times of old mean. So a x bar whole square upon n. So if we take a common, it becomes sigma a square xi minus x bar whole square upon n under root. Now let's take this a square outside, but we'll write it as mod a because we are only considering the positive values. The inside it will be sigma xi minus x bar whole square upon n. Now, therefore, the new standard deviation is nothing but mod a times of the old standard deviation. So when we multiply or divide a constant value with a, the standard deviation will also get multiplied with the constant value. Similarly, the variance will also be a square times of the old variance. So a small recap over here. When we add or subtract a constant, the new mean will be old mean plus constant, and standard deviation, new standard deviation will be equal to old standard deviation. They do not change. Similarly, the variance, that is square of standard deviation, will also doesn't change. Next, when we multiply or divide a constant, multiply or divide a constant, the new mean will be constant times of old mean. Here, standard deviation and variance both changes. How? Standard deviation, new standard deviation will be mod constant times of old standard deviation. Similarly, variance will be, that is square of standard deviation is equal to constant square into variance of old. So these are the things you need to remember because these are applied in solving questions. So let's solve few questions so that you'll get a clear idea how to use and where to use this kind of tricks. In this question, it is given the mean of 30 observations is 75. So there are 30 observations and mean, that is old mean or the original mean, is 75. If each observation is multiplied and each observation is multiplied by a non-zero number lambda. So first suppose original data is something like x1, x2, so on till 30. But now each observation is multiplied by lambda. So it becomes lambda times of x1, lambda times of x2, so on till lambda times of x30. For this, mean is this, and then each of them is decreased by 25. First multiplied, now we need to decrease by 25. That is lambda x1 minus 25, lambda x2 minus 25, so on till lambda x30 minus 25. Now this is the new data. For this, the mean is same. Mean remain as it is. So the new mean is equal to the old mean, that is 75. We need to find the value of lambda. So just now we have discussed for the data, first we have multiplied. So what happens when we multiply a constant? How the mean changes? The mean changes as lambda times of the old mean. And we are also subtracting, decreasing by 25. 25 is again a constant. So the new mean will be this lambda x naught or the x original minus 25. Because just now we have discussed when we add or subtract a constant value in the data, the mean also behave as it is. Matlab, it also either increases or decreases with the constant value. So now this is the new mean. Just equate this value with 75. So lambda into original mean is 75 minus 25 is equal to 75. It becomes 75 lambda is equal to 100. Lambda is 4 by 3. Therefore, according to the question, B option is the required answer. Here, in this question, it is given there are 10 observations with the data points xi and I ranges from 1 to 10. If these values are given to you and we need to find the standard deviation of the data. Generally, what will be the standard deviation formula? It will be sigma computational formula xi square upon n minus mean ka square under root. This can also be written as sigma xi square upon n minus mean is nothing but sigma xi upon n whole square. So this is the actual standard deviation and this we need to find out in this question. But what values are given to us? When a p is a constant value over here, when it is subtracted, one thing you need to remember is when we subtract or add a constant, standard deviation doesn't change. So here also, let us do that. Standard deviation will be sigma xi minus p whole square upon n minus sigma xi minus p upon n whole square. And this all comes in the under root. Why am I doing like this? Because when we subtract or add a constant, the standard deviation doesn't change. So now this value we need to find out and that's gonna be the answer to this question. So sigma xi minus p whole square value is given to you, that is 9. N is the total number of observation, that is 10 minus sigma xi minus p value is given, that is 3 upon 10 whole square. 9 by 10 minus 9 by 100 under root. The final answer standard deviation will be 9 by 10. So option C is the required answer to this question. In this question, again, observations are given in the format of xi and I ranges from 1 to 10. So there are 10 observations, which satisfies these two equations. If mu and lambda are the mean and variance of the observations which are given to you in this format. And we need to find out the value of nu and lambda. So these kind of questions have very regularly appeared in JEE exam. So make sure you are clear in this concept. Okay. So first, here actually there are three data types. That is, first is the XI, which is an original data observations, and next it is XI minus 5 observation. These are the type of data points. Next, we need to find for XI minus 3. So these are the data types. These are the observation types in this question. So for this, let us calculate mean and variance separately. For us, what values are given? The values related to xi minus 5. So this second type of data observation, for this the values are given. So let's use it. So this will be mean 1, mean 2 and mean 3. So let us calculate mean 2 now. That is, mean 2 is nothing but sigma xi minus 5 upon n. Right, we are calculating for this. So this value is given to you, that is 10. And total number of observation I have told you, that is 10. So mean will be 1. So this is the value of x2. That is mean 2. Now, how do you calculate mean 1? This is the original mean. Just now we have discussed, when we add or subtract a value, a constant value, the mean also behaves accordingly. So the new mean will be the old mean plus the constant value, right? Here, what is the new mean? New mean is nothing but mean 2, that is 1. Old mean, we need to find out. And what's the constant value? That is minus 5. From this, you will get the original mean as 6. So, mean 1 is nothing but 6. Similarly, we need to find the mean 3. For the mean 3 also, a constant value is getting subtracted. So for this, it becomes original mean plus constant value. So original mean, just now we have calculated, that is 6. Constant is minus 3. So therefore, mean 3 will be 3. Okay. In this way, we'll calculate the means of the different data types. Now, this is the value of nu, right? Here, nu is the mean of this observations. Now, let us calculate the variance. So, again, we'll calculate the variance for the second data type. So, it becomes like this, that is sigma xi minus 5 whole square upon n minus mean 2 square. So, this value is given to you, that is 40. 40 upon 10 minus mean, that is 1 square, which is 4 minus 1, 3. So variance is nothing but 3. Now, a very important thing over here is, just recap the thing. When we add or subtract a constant value to the data, will the variance change? Will the variance change? No, right? So the variance will remain as it is. So this is the value of lambda in this question. So nu we got, lambda we got. Just see which option is correct. 3 comma 3. So option A is the required answer to this question. In this question, there are 10 observations and the mean and standard deviation of these 10 observations are given to you, that is 20 and 2 respectively. Each of these 10 observations is multiplied by a constant value p and then reduced by a constant value q. And make sure that p is a not equal to 0 and q is also not equal to 0. If the new mean and the new standard deviation become half of their original values, then what will be the value of q? So there are 10 observations and original mean is 20 and original standard deviation is 2. And the new mean is said to be the half of the original value, that is half of the 20 will be 10. Similarly, new standard deviation will be original upon 2. So it becomes 1. Now, here it is told first the data points are getting multiplied and then reduced. So according to this, new mean will also get multiplied first with the original mean and then reduced by a constant value q. Now this is equal to 10. So original mean is nothing but 20. So 20p minus q is equal to 10. So this is the equation number 1. Next, what about the standard deviation? So the new standard deviation will be, here the data is getting multiplied with a constant value p. So it becomes p times of original standard deviation. It is reduced next, but standard deviation remains as it is if you reduce or increase by a constant value. Now this equated with 1. Original is 2. It becomes 2p is equal to 1. So when you simplify this, you will get p is equal to half. So when you substitute this p over here, you will get this 10 and this 10 will get cancelled. You will get q as 0. But do you have any option? And in the question, it is also told that q should not be equal to 0. So somewhere we have done a mistake. Where it is, if you clearly observe, in the standard deviation, we need to take the mod value of the constant, right? So this absolute thing is very important. So it becomes 2 times of mod p is equal to 1. From here, we'll get p is equal to plus or minus half. So if p is equal to plus half, you will get q as 0. Just now we have seen. And if p is equal to minus half, then from the equation 1, it becomes 20 into minus half minus q is equal to 10. So from here, we'll get q as minus 20. So option C is the required answer to this question. So one thing to remember here is, for the new standard deviation, we'll always take the mod value of the constant. So just keep this in mind.